Okay, now we are going to see an introduction to classical set. Okay, so what is set? A set is an unordered collection of different elements. So here the order of the elements is not mandatory, right? So here I am grouping different elements, right? So there are two examples here. So the first is set of vowels in English alphabet. So which is given by the set A. So A is opening braces and closing braces. So which consists of vowels A, E, I, O, U. So next is set of odd numbers but with a condition which are less than 10. So obviously the set B is 1, 3, 5, 7, 9. So these are all the odd numbers which are less than 10, right? Okay. So next is set builder notation. So what do you mean by builder notation? So here I am specifying a property. So that property must be satisfied by all the elements of the set. Okay. So take the same two example sets. So how can you give a general notation? So A is equal to X. So X is an element, whereas P of X is the property of the element. So whatever be the element in the given set, so that must satisfy the property P of X. So take the first set. So set of vowels. So how can you indicate those? So this is given by A. So A equal to X colon. So that is such that X is a vowel in English alphabet. So this is the builder notation. So come to the second set 1, 3, 5, 7, 9. So here there are two conditions. So the first condition is the value must be less than 10 and second is odd number, right? So the first is the X value must be in the range 1 to 10. Okay. So second, how can you check whether the given number is odd or even? Right, I am checking the mod value. So the remainder is not equal to 0, then the number is known as odd number, else it is even number. So this is the way of representing the set, right? So next is belongs to and not belongs to. So if an element is a member of the set S, then which is denoted by X belongs to S. So else, so that means if an element is not a member of set S, then it is indicated by the symbol not belongs to. So that take the example set S, so which consists of 4 elements, namely 1, 1.2, 1.7 and 2, right? So now I am checking 1. So now 1 belongs to S because 1 presents in this set S, right? So take 1.5. Is there any member 1.5 in this set S? No. Okay. So now 1.5 is not belongs to the set S. Okay. So the last is cardinality. So what do you mean by cardinality of a set? So that is the number of elements of the set. Okay. So which is indicated by determinant. So determinant of S. Okay. So see this example set 1, 4, 3, 5. So how many elements are there in this set? 4. Okay. So now the cardinality is also 4. So come to a set of natural numbers 1, 2, 3, 4, 5. It's going on, right? So now we can't predict the number of elements. So if a set has an infinite number of elements, now the cardinality is infinitive. So which is given by here. Okay. So that's all about cardinality of the set.